Newton's first law of motion. Every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it.
Here we have three still objects that, using Newton's first law of motion, will remain still until an external force will be applied to them. The first object is a book with no forces applied to it besides gravity, but the desk limits gravity's potential power. Here we have another book that will be tested on with an external force, like my hand. You can see that when I apply my hand, when I push the book, it moves. Here, when I give it another push, it slides. Of course, friction stops the book from sliding to infinity. The book still was in motion when forces were applied. Another way to prove Newton's first law of motion is using a different object, applying force to it to push another object, this way.
Newton's second law of motion. The relationship between an object's mass, m, its acceleration, a, and the applied force, F, is F equals ma. In these laws, the direction of the force vector is the same as the direction of the acceleration vector.
Mass, acceleration, and forces. Let's say the mass of this book with the force of my hand is being pushed at an x acceleration. Now, when the mass is doubled, there needs to be more forces applied to push this. If you raise the force, then it should equalize them. Yet the relationship between them says that the forces will still be powerful enough to move this. The acceleration will not be as fast as the previous experiment.
Newton's third law of motion. For every action, there is an equal and opposite reaction.
For every action, there will be an equal or opposite reaction. When the tennis ball is thrown at the wall, it will bounce back at the same velocity it came.